Hello, everyone. Cancer, a word that strikes fear into the hearts of many and touches the lives of millions across the world. It is a pervasive disease characterized by uncontrolled cell growth and invasion, claiming countless lives every year. Now, as I dove into cutting-edge cancer research, I discovered an interesting intersection of nanotechnology and oncology, and it became evident to me that nanoparticles possessed immense potential in cancer therapy, especially in drug delivery systems. But I realized that widespread adoption of this technology was difficult because of its high cost and difficulty in accessibility. So, hoping to simplify this complex problem, I decided to explore the synergistic potential of nanoparticles when combined with conventional cancer drugs. So I selected zinc oxide nanoparticles as my focus, along with the widely used chemo drug cisplatin and PC3 prostate cancer cells as my test subject. This method aimed to understand whether integration of nanoparticles could enhance the efficacy of existing cancer treatments. The methods I used was cytotoxicity assays and RT-qPCR. For the cytotoxicity assay, I measured the individual cytotoxicity of varying doses of cisplatin and zinc oxide nanoparticles before combining them and having mixed doses run again. For RT-qPCR, I explored the expression of caspase-3 gene, which is an apoptosis gene, and I sought to see if there was an increase in apoptosis when the mixed dose was used. My results were rather mixed. The individual doses of cisplatin, despite going as high as 1000 micromolar, did not show any decrease in cell viability, despite literature having suggested a far lower dose for cytotoxicity. For zinc oxide nanoparticles, other nanoparticles did need a higher dose, but with zinc oxide nanoparticles, I discovered cell viability decreased at doses as low as 400 nanogram per mil. But when the mixed doses were used, there was no decrease in cell viability. That was significant, despite having used a nanoparticle dose that definitely had a significant decrease in cell viability when in the individual dose run. Now, as for the RT-qPCR, the individual doses of cisplatin and zinc oxide did not have any significant increase in caspase-3 expression, but the mixed dose did have a significant increase, which shows that the apoptosis gene was being there was an increased regulation of the apoptosis gene when the mixed dose was used. I believe the mixed results were most probably due to errors or discrepancies in sample preparation, which has multiple different solvents that could have been used. So optimizing better solvents and testing them before being used should give us a more uniform result across both methods used. But just based on RT-qPCR, I can confidently say that this avenue of exploration and research does have some potential and could be used as a valid method in the future, or as a cheaper option in areas that cannot access this complex technology. For future directions, I believe anyone exploring this avenue should first use a isobolographic analysis or a combination index analysis to first determine a synergistic dose of each of these compounds before moving on to cytotoxicity assays or RT-qPCR, so that they would have a more uniform result and a much better method validation. I also believe it is imperative to test these doses on non-cancerous cells to make sure that they do not affect healthy cells. Thank you for listening.